Okay, so my first differentiation will be a function can be divided into two types of function, which is one and many one, right? So let us take the same example. A, B, we have 1, 2, 3, 1, 4, 9. So 1 is related to 1, 2 is related to 4, and 3 is related to 9. 1, 1, right? One element of A and one element of B are related to each other. Now, many one, what will happen? Right? My function is what? My function is f of x is what? X square. Right? I am using this function. So, in this case, 1 and minus 1 both are related to 1. Right? So, we are using the term many 1. Clear? 1, 1, many 1. When one element is related to only one element of B, or where two elements of A are related to one element of B. What kind of order pair will be? Here the second element is being repeated. Here second element is also not repeated. Correct? So in 1, 1 function, second element, that is the element from the codomain set, or you can say the range set, is not repeated. However, in many one, the range set is repeated twice, thrice, or as many number, depending on the function. Right? This 1, 1 function have another name. We call it as injective or injection. Right now, injective function. Right? Now, let us take one example. How to prove a certain function as my 1, 1 function. Right? Clearly, this is not my 1, 1 function. Right? So, let us say, suppose my function f(x) is equal to some x plus 3. I am taking very simple example, but you can apply the same method to all the examples, right? All the problems. So we will start with a statement like f(x1) is equal to f(x2). What is the meaning of this? f(x1) is equal to f(x2) means that we are assuming that our second element is same. Whenever there is a function f(x) is equal to x something, right now, this is my first element and this is my second element. When this is my domain set, this is my codomain, or you can say from range. Alright. So what I am assuming? I am assuming that my second element is same. Now, what is f(x1)? It will be like x1 plus 3. What is f(x2)? x2 plus 3, using x1 and x2. 3 will get cancelled. What do we get? We get x1 is equal to x2. It means if we take second element as same, my first element is also same. It means there is no repetition of any order pair, right? So you can say x1 f(x1). This is my order pair, right? This is same as x2 and f(x2), because if we take f(x1) as same, my x1 is also x2. So no repetition of second element is there, right? Only if x1 is not equal to x2, in that case it will become many one function. Here it is 1, 1. Correct? Let us see how we can prove it is many one. Same. We will take another example. Take this as example. Fx is equal to what? My x square. Okay. Same method. We will start with assuming that our second element is same. Right. So here it will be x1 square is equal to what? x2 square. Right. This will give me two scenarios. First one, either x1 will be equal to x2 or x1 can be minus x2. In both case we will get this x1 square is equal to x2 square. Hence we are getting two conditions here, right? If there is only one condition, and that is also where x1 is equal to x2, it is 1 1. But if we get more than one condition, it is not 1 1. So it will be many 1. So this is the method to prove whether a function is 1 1 or many 1. Just assume that the second element is same, fx1 is equal to fx2, and prove it that the first element is also same. Hence it will be 1 1. If it is not proved that the first element is not equal to second element, or you are getting a different condition also, then it will be many 1. This is my many 1 function. Yeah. Now let us differentiate functions into some other categories. Okay, this category involves the function to be divided into two types. One is called as onto, another is called as into. Right? Let us understand what these functions are. Now, in the earlier examples, we have taken the two sets A and B. Right? Now, it is clearly that elements of B is square of elements of A. Now, onto is a function when the B set, means the codomain set, has no elements left in it. Okay, if we pair up all the relations, all the relation of the function, right? It means if we pair up, find the pairs of function. For example, in this function we have 1 1, 2 4 and 3 9. Correct? So no elements of B is left out. Right? This function is called as onto function. I remember this function as the first letter O, which also represents 0. It means 0 elements left in B. It is known as onto function. Okay, another definition could be that the range should be equal to codomain. When the range of a function is equal to its codomain, it is known as onto function. Right? So no elements of B is left. Second case, when the elements of B is left for any image, right? Clearly 10 has no elements in A. Right? 10 is the element in B which has no element related in A. Hence it is known as my into function. Right? Now onto is also known as surjective function. Right? Remember 1 1 function? 1 1 function was known as injective. This onto function is known as surjective. Now a function can have 4 combinations. Right? It can have 1 1 onto, 1 1 into, right? Many 1 onto, many 1 into, right? So we can have 4 types of combination in a function. Now this 1 1 and onto, it means injective also, surjective also. This is known as bijective. Right? Continue. both the functions, on1 and on2, right? It is known as bijective. Now we will understand how to prove a function as onto, right? We already done the function to prove on1, right? Now in this lecture we will learn how to prove it onto. I have taken two examples. First example, it will be proved as onto. Second example, it will be proved as not onto or into. Okay, let us see how we can prove it. Okay, the first example is fx is equal to 2x cubed minus 5. Now here the definition of function is also very important, right? In definition you will get that what values x can take. Here I am assuming that x can take all real numbers. Okay, all real numbers. Now the first step would be that take it as y. Right? We have denoted fx as y. What we will do, we will change the function in terms of y. This function is basically what? In terms of x. We will convert this function in terms of y. How we can do this? Let's see. So it will become 2x cube is equal to what? Y plus 5. 5 is coming here. So x cube is y plus 5 by 2 and x is y plus 5 by 2 1 by 3 cube root, right? So now this function is in terms of y now, right? So basically what we are doing, we are separating x and y differently, right? Now here x was independent term and y was dependent. Now we have made x depending on y, right? So same method while you are proving onto or into, right? So here now we will check. We know that x can take any values, right? Here we will get the value of y. Can we take any value here also of y? Is there any restriction in y? Of course, in this example there is no restriction. I can take any values of y. It means y also belongs to what? Real number. It means all the values of y, when we get this kind of equation where we can take all the values of y, it means that all the values of y will have an image in A, right? A is basically what? Where x comes from, B where y comes from, right? So we are saying that y belongs to real number. It means all the values of y we have an image in A also, hence it is an onto function. This is my onto function. Let's see another example. Here also the fx is equal to 2x upon 1 plus 2x, right? So if we take this as y and then interchange the place of y, or we can do this y 1 plus 2x is equal to y upon 2. Right. Got the value? Now here we can see that we cannot take y as 1. Okay, because in the denominator if we take y as 1, then there is no value of x we will get, right? So there it is not defined, right? So we cannot take y as 1. For y is equal to 1, we don't have any values of x. It means we cannot have this function as onto. one is left out. Okay, in that set, in set B, 1 is the element which has no pre-image in A, means no elements related in A, related with A. Correct? So this way we can find out whether the function is onto or into. Now to prove a function as bijective, you need to prove 1 1 also and onto also.